What if I told you there's a scale that can measure exactly how advanced a civilization can be? I'm not talking about technology, money, or knowledge. I'm talking about something far more fundamental: energy. Imagine for a moment that you could capture all the energy your country consumes in an entire year and concentrate it in your hands. Now multiply that by millions, then by billions, and then by trillions. It's almost impossible to even imagine, isn't it? Well, there's a scientific classification that does exactly that. It organizes entire civilizations based on how much energy they can harness and control. And when you discover where humanity fits on this scale, and especially where we could go, your perspective on the future will change completely. We're talking about the Kardashev scale, an idea born in 1964 in the mind of Soviet astrophysicist Nikolai Kardashev. At the time, humanity was taking its first steps into space, launching satellites and dreaming of lunar missions. But Kardashev was thinking far beyond that. He envisioned civilizations that could use entire stars as cosmic batteries, that would transform galaxies into their personal power plants. The genius of Kardashev's idea lies in its universal simplicity. Think about it this way. It doesn't matter whether a civilization is made up of beings like us, super-intelligent robots, or something completely unimaginable. Every advanced form of life needs one thing above all else: energy. Energy is what enables building, traveling, computing, and communicating. Energy is what separates a primitive tribe from a galactic empire. When we examine this scale, we discover it divides into three main types, each representing a leap that's almost impossible to imagine. A Type 1 civilization can harness all the energy available on its home planet. This means capturing not just the sunlight that reaches there, but also the energy from volcanoes, oceans, winds, and tides. We're talking about something around 10 to the 16th power watts. To put that in perspective, that's more energy than all of humanity has ever used throughout our entire history. But that's just the first step. A Type 2 civilization goes beyond that, far beyond. It can capture and utilize all the energy radiated by its star. All of it, not just the tiny fraction that reaches its planet, but 100% of the energy the star produces. This equals roughly 10 to the 26th power watts. To achieve this, such a civilization would need to build something that seems straight out of a dream, a gigantic structure around the star, capable of absorbing all its light. And then we reach Type 3, which is where things become truly epic. These civilizations harness the energy of an entire galaxy. Billions of stars, each one being used as a personal power plant. We're talking about 10 to the 36th power watts. It's such an absurd number that our minds simply cannot process it. For reference, it would be like comparing an ant to planet Earth. Now here's the part that might make you a bit uncomfortable. With all our technology, our smartphones, our internet, our space travel, we haven't even reached Type 1 yet. Humanity currently sits at level 0.73 on the scale. That might seem close, but it's actually like standing on the first floor of a building and looking up at the top. You can see where you want to go, but you still have a very long way to climb. This isn't necessarily bad news. In fact, being at 0.73 means we're making progress. 200 years ago, we would have been much lower on the scale. And if we maintain our current rate of development, some scientists estimate we could reach Type 1 in about 200 years. Of course, that depends on not destroying ourselves first and managing to solve some fundamental problems. To become a Type 1 civilization, we need to learn how to efficiently capture and use all the energy our planet receives from the sun. And here's a fact that might blow your mind. The amount of solar energy that hits Earth in just 1 hour is enough to power all of human civilization for an entire year. The problem isn't energy availability. It's our ability to capture and store it. Imagine if we could cover just a small fraction of the world's deserts with super-efficient solar panels. Or better yet, imagine if we could build solar farms in space, where there are no clouds, no night, and solar energy is constant. This isn't science fiction. It's technology that's already being seriously developed by companies and space agencies around the world. But solar energy is only part of the equation. To truly make the leap to Type 1, we'll probably need to master something the sun has been doing naturally for billions of years: nuclear fusion. In the sun's core, Hydrogen atoms fuse together to form helium, releasing an astronomical amount of energy in the process. If we could replicate this in a controlled way here on Earth, we'd have a clean, safe, and practically infinite energy source. The difference between fusion and nuclear fission is like the difference between lighting a candle and exploding dynamite. Fission, which we use in current nuclear power plants, splits heavy atoms and produces dangerous radioactive waste. Fusion, on the other hand, combines light atoms and produces only harmless helium as a byproduct. The problem is that making this work requires temperatures of over 100 million degrees Celsius, hotter than the sun's core. Projects like ITER in France and various American startups are getting closer and closer to making this a reality. When we succeed, it will be like opening a cosmic faucet of clean energy. Our dependence on fossil fuels will become history, and we'll be ready to take the next giant leap. But what if we wanted to go beyond Type 1? What if we wanted to capture not just the energy that reaches our planet, but all the energy our star produces? That would take us into the realm of Type 2, and that's where things get truly spectacular. To become a Type 2 civilization, we'd need to build something Freeman Dyson imagined in 1960, a structure around the sun capable of capturing all its energy. It wouldn't be a solid sphere. That would be impossible to build and maintain. Instead, it would be a swarm of millions or billions of energy-collecting satellites, orbiting the sun in perfect synchronization. Building something like this would require resources that simply don't exist on Earth. We'd have to dismantle entire planets to get enough material. Mercury, for example, would be a perfect candidate. It's rich in metals and close enough to the sun to be useful. Autonomous mining robots could slowly disassemble the planet and use its materials to build the collector satellites. This might seem impossible, but remember, we're talking about a civilization that has already mastered all the energy of its home planet. They'd have practically unlimited energy resources to dedicate to stellar-scale engineering projects. And with self-replicating robots, machines that can make copies of themselves, such a project could grow exponentially. A Type 2 civilization would probably be very different from us. Perhaps not even biological anymore. Think about it. Organic bodies have limitations. We need food, water, oxygen, and we have relatively short lifespans. But a digital consciousness, distributed across millions of computers throughout the solar system, could exist for thousands or millions of years. This leads us to a fascinating and somewhat disturbing possibility. What if the natural destiny of any intelligent civilization is to eventually become post-biological? What if, as we advance up the Kardashev scale, we leave our physical bodies behind and become something completely different? Think about the advantages. Without physical bodies to limit them, a civilization could spread throughout the entire solar system instantly. It could process information on scales that would make our best supercomputers look like pocket calculators. It could build and maintain gigantic structures over time periods that would make our greatest architectural works seem like sandcastles. And this brings us to Type 3, civilizations that harness the energy of an entire galaxy. To reach this level, a civilization would need to send fleets of self-replicating robots to every solar system in the galaxy, building energy collection structures around each star. It would be a project spanning millions of years, but for an immortal digital consciousness, time would be just another resource to manage. A Type 3 civilization would have enough power to do things that challenge our imagination. It could move entire stars, create artificial black holes, or even manipulate the structure of space-time itself. It would be, in every sense, a civilization of gods. But here's the big question that haunts scientists. If such civilizations are possible, where are they? Why don't we see evidence of structures around distant stars? Why don't we detect the infrared signatures that a Dyson sphere should produce? Projects like SETI, the search for extraterrestrial intelligence, have been scanning the skies for decades, looking for signs of advanced civilizations. They search for radio transmissions, unusual light patterns, thermal signatures that would indicate megastructures. But so far, they've found only silence. This leads us to some unsettling possibilities. Maybe advanced civilizations simply don't want to be found. If you had the power to manipulate stars, would you announce your presence to primitive civilizations like ours? Or maybe we're looking in the wrong places, or in the wrong way. There's also the possibility that we're among the first. In a universe with billions of galaxies and trillions of planets, this might seem unlikely, but it's not impossible. Maybe intelligent life is much rarer than we imagine. Maybe the combination of factors needed to produce a civilization capable of climbing the Kardashev scale is so specific that it's barely happened a few times in all of cosmic history. Or perhaps, and this is the darkest possibility, there's something that prevents civilizations from progressing beyond a certain point. Some kind of filter or barrier that causes them to self-destruct before they can master stellar energy. Wars, environmental collapse, uncontrolled development of artificial intelligence. There are many ways a civilization can stumble on its way up the scale. If that's the case, then our current position is even more precarious than it seems. We're at a critical point in our history, where our decisions over the next few centuries could determine whether we join the ranks of advanced civilizations or become just another species that couldn't overcome its own limitations. But there are reasons for optimism. Our understanding of physics is advancing rapidly. Our technology is developing at an exponential pace, and most importantly, we're beginning to understand our position in the cosmos and the responsibility that comes with it. The Kardashev scale isn't just a scientific measure. It's a mirror that reflects who we are and who we can become. Every advance in renewable energy, every step forward in nuclear fusion, every move towards space exploration pushes us a little further up the scale. And every choice we make about how to use our technology defines whether we'll be a civilization that builds or one that destroys. Maybe that's what makes the Kardashev scale so fascinating. It's not just about energy or technology. It's about the future of consciousness in the universe. It's about the question of whether intelligence and creativity can overcome entropy and destruction. It's about discovering whether we're just a temporary cosmic curiosity or whether we have the potential to become something truly extraordinary. So the next time you look up at the night sky, remember that every star you see is a potential power plant. Every distant galaxy is a realm that a sufficiently advanced civilization could call home. And we, here on Earth, are the first known members of this cosmic community, carrying the weight and opportunity of representing intelligent life in the universe. If you found this journey through the Kardashev scale as fascinating as I did, don't forget to subscribe to the channel and turn on notifications. There are many more mysteries of the universe waiting to be explored, and each one helps us better understand our place in the cosmos. Because knowledge is just the beginning.